Hi everyone. We're going to look at some more examples with quadratic equations or quadratic functions and looking at their graphs, interpreting the graph, finding the maxima minima. And for that we're going to utilize what is called the standard form. Right. So we already know based on because the coefficient of x squared is negative, this is downward facing. Okay, so that's already established. The first part says express it in standard form. So let's go ahead. We write f(x) is negative x squared plus x plus 2. I always factor out the coefficient of x squared because I want it to be 1, and I leave the 2 as it is. Right? Now, in my scratch here, I notice that to get this x, I'm going to have an x minus 1/2 squared, because then I get x squared minus 2 times 1/2, which is 1, so 1x plus 1/4. What I'm missing is the 1/4. So I create the 1/4 I need and I subtract the 1/4 so that I haven't made any real change. Then I keep one of the 1/4, which is going to help me make the square. Negative 1 times negative 4 is positive 1/4. And the reason I did all of this is to have x minus 1/2 squared and 9/4 here. Okay, so this is my equation in a standard form. This is standard form. Now, as soon as I put things in the standard form, it's very easy for me to sketch the graph, right? Because the vertex is immediately obvious. The vertex is 1/2 comma 9/4. Why? Because we are saying that this entire thing is going to be max if this negative part is minimum. And this negative part, the minimum value it can take is 0 because it's a square. And that happens at exactly x equals 1/2. And when that happens, f of x equals 9/4. So that's the vertex. We still need to work on the intercept, right? So the y-intercept, that's going to be x is 0, so negative 1, negative 1/2 squared plus 9/4, negative 1/4 plus 9/4, 8/4, which is 2. And then x-intercept is when negative 1 x minus 1/2 squared plus 9/4 is 0, or x minus 1/2 squared is 9/4, x minus 1/2 is plus minus 3/2, x is negative 3/2 plus minus 3/2 plus 1/2. So 3/2 plus half is 2, and negative 3/2 plus half is negative 1. So my graph, I have an x-intercept at 2, I have an x-intercept at negative 1, I have a y-intercept at 2, I have a vertex at 1/2 and 9/4. 9/4 is slightly more than 2, so it's somewhere here. 1/2 and 9/4. And then I connect these points, and it is downward facing because the coefficient of x squared is negative. And the max value is 9/4. Okay. Now let us do this in the general case so that we can solve it once and for all. Now this derivation here should be reminiscent of how the formula for the quadratic formula is derived, which is again something that you learn in 103 towards the end of your factoring journey. So for the general case as well, the strategy remains the same in that I do not want to have to deal with this a. So I factor out an a, which gives me a b over a times x plus c. Yeah, I leave the c as it is because I'm going to deal with it at a later time. And then I notice that this can be obtained by taking x plus b over 2a squared. Right? It's always half the coefficient of x. This gives me what I need, which is b over ax, but it gives me this additional b squared over 4a squared. Right, with that additional b squared over 4a squared, this becomes a times x squared plus b over ax. So I add what I need, but then I also remove that, plus c, and I keep what I need, which is x squared plus b over ax plus b squared over 4a squared minus a times this gives me a b squared over 4a plus c. But what is this? The whole point was to write this as x plus b over 2a squared, right? Plus c minus b squared over 4a, or maybe let me write that as I take the LCM, it's 4a, so it's 4ac minus b squared. So now my general form has been converted into the standard form. And then we use the same logic, meaning for this to be minimum, this must be 0, right? So the vertex will be at x equals negative b over 2a, and when x is negative b over 2a, this whole thing is 0, so f of x is c minus b squared over 4a, which means the vertex is negative b over 2a, comma c minus b squared over 4a. Now at this point you have the option to use this formula for the vertex when quadratic is in the general form. However, my suggestion is not to waste your time trying to remember this, because you can always use the actual method, which is just completion of square, to figure this out case by case. Okay, let's look at a word problem. Let's read through the word problem first. What's happening here? It says a hockey team plays in an arena that has a seating capacity of 15,000 spectators. With the ticket price set at $14, average attendance at recent games has been 9,500. A market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. Find a function that models the revenue in terms of the ticket price. So, first of all, we are talking about revenue and ticket price. So let's give them variables. Let's call this R, let's call this T. So our goal is to find RT, right, which is revenue in terms of ticket price. Okay. It says average attendance is 9,500. That for each dollar the ticket price is lowered, the average attendance increases by 1,000. Okay. Now the basic model is going to say that whatever money you make, the revenue is going to depend on the ticket price and multiplied by the number of people who attend. All right. Now, let's say T is the ticket price. Right. Now, the average ticket price is set at 14. So, what is the amount that the ticket price is lowered by is going to be whatever you get by subtracting T from 14. And the increase in attendance, it says that for every dollar that you do that, you get 1,000 more people. So for example, if T was 7, so you lowered $7, it would be 7,000. So it's 1,000 times 14 minus T. And what is the actual attendance? Is we already know that 9,500 people are going to attend for sure, and then it's additional 1,000 for whatever we reduce, which gives me that revenue must be the ticket price times the attendance, and the attendance is 9,500 plus 1,000 times 14 minus T. And what is that? That is T times 14,000 plus 9,500 is 23,500 minus 1,000 times T, which ends up becoming this quadratic 23,500 T minus 1,000 T squared. Okay. So that's the function that models a revenue in terms of ticket price. Now for maximize RT, right? To maximize RT, how many tickets do you need to sell? It's going to be negative B over 2A, right? Where this is A and this is B. So it's negative 23,500 over 2 times 1,000, which comes out to $11.25. So that should be the price in order to maximize, right? And then for what price nobody attends? For what price nobody attends? Which is basically finding one of the intercepts. Nobody attends. For nobody to be attend, to attend, you want the revenue to be 0, right? So that means you want RT to be 0, and that happens exactly when this is 0. So 23,500 over 1,000 equals T, or when T equals $23.5. So if you put the cost of the ticket as $23.5, nobody's going to attend and you make no money. So that's an example of a real life situation where the model that you create results in a quadratic function, and we can use the vertex and the min-max arguments to get meaningful results out of it. All right, that's it. Thank you.